The law of sines. You've learned this before. So the key here being that A is across from A, B is across from B, and little c is across from C. Little letters are side lengths. Capital letters are angles. This is the law of cosines. This is form one of 6 different versions of this. I say just remember the one and solve the equation.
Oh, isn't that the law of cosine?
That's law of cosines, yeah. Which is the Pythagorean theorem for non-right triangles. You just have to add the minus 2ab cosine c. And I'm always of the impression that I don't care what they label it. I'll label C the side, or I don't know, or the angle I'm trying to find. I'll just cross out whatever labels are there, relabel them, and think about them as positions. I can change the letters to whatever I want, but it's all about the positions. And there's some proof in here. I recorded a video on how to prove this. So
Thank you.
find the value of B. The proofs actually aren't that hard. They're probably worth spending the 10 minutes watching and understand. The more you understand, the better you'll do. So this one, sine 70 over B equals sine 30 over 7.
I remember this.
Times B. Then we'll divide by sine 30. And we get B equals, I'm going to look up the answer because save the time on sticking it into a calculator. 13.15. So 13.2. 3 sig figs. It does not have any units, so we're done. Wants F. Over 7 equals sine F over 6. I don't believe in fully cross multiplying here. I only do half. And to get F, I will do an inverse sine. And that equals 45.3. Wow, I don't like how they notated that, but you know. I think for triangles, your default is going to be 8 degrees unless otherwise told. I think that's kind of the default for this class. So now we've got the law of cosines. So law of sines is good for side, angle, angle, side, and angle, side, angle. And sometimes side, side, angle.
I recognize them when I see them. That's all I have to say for myself.
These side angle side or side, 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 where you're trying to find an angle, you want to use the law of cosines.
Because there are two sides and one angle.
Mhm. So this is a perfect example of the easy version of law of cosines.
Running.
You only need one angle. Then there's some cases where you can do law of sines, and in pre-calc we did the ambiguous case. I don't think you have to do that here. Pretty sure you don't have to do that. And you stick this in the calculator, you get c squared, or you square root it. Like, just do not do this in steps. Stick it in the calculator in one piece, and you get 3.62. Okay, this time the triangle ABC we have found, and the length of BC.
Yes.
I don't want to use the law of cosines on this one.
Is it because you don't have A? They need A, B, and angle?
Yeah.
Or-
I think they're gonna show it using. They're gonna use this, and I suppose you could solve by graphing.
Use either.
Yeah,
There's less algebra in
the law. You could solve by graphing, which is what they did.
I don't know how to do that.
Yeah, you do. You just call these x and find what equals 36. F1 of x, F2 of x equals 25 plus x squared minus 10a cosine 86. Graph them, find the intersection point. I would do this by law of sines. That's fine. I would do sine 86 over 6 equals sine a over 5. Can I borrow your calculator? Or could you do this calculation? 5 sine 86 over 6.
In degrees, it's 0.8313 seconds. Oh, because we're gonna take the
And then you're going
inverse.
to take the inverse sine of that to get a.
No, Steve, I didn't mean good on it.
Okay, I'll just.
56.24. So 56.2.
Okay.
And. Okay, it's your short mark.
Let me finish my lesson, then I'll help you. So I cross multiply and then I'm going to divide and I'll get to this. And what do you get for a when you stick that in?
I guess I should have gone. We're on the 6 sine 56.
Yep, 0.23 over sine 86.
What's that? Wow. 1.66667. Did I enter this in right?
No, it's supposed to be 6 times sine, not 2 times sine. You could multiply it by 3, which
I
feels
thought I typed a 6 in. 5.
You get 5? Why do we get a different answer?
Here.
Let's see if the original.
You should tell me. Sometimes I just type things in a second time and then I get completely different answers, which is scary.
Hmm. That's right. So the problem with law of signs on this one is it doesn't guarantee a a brain. My brain needs to work. Doesn't guarantee a because it's side angle. Long side, short side angle should work. That does work. Why are we not getting the same answer? Oh, that's C. I'm being a dope.
Why didn't catch it either, so it's okay.
This is angle C. Is 56.23.
Oh.
That makes sense. So this is
Right.
33.77.
Interesting.
I'm trying to rush through the lesson.
It's okay.
That makes way more sense. I thought that was a big angle for how it looked.
Oh. Oh, because it's almost a 30, 60, 90. This makes sense. It's like
I still get a different answer. Did I subtract right? Yes, I did. I get 33.77. The question is, what do I get when I graph?
Is there some radius?
No, better not be.
Why it would be Janus.
They gave it in degrees. So I graph it. And they do get 3.68. Well,
I'm so confused.
I don't know why the law of science isn't working. I'll get back to you on that.
Okay.
We're gonna move on. So this one,
I
what,
love
what
the
is,
dog.
what does it want us to find? Find the size of ABC. So that's this angle B. 16 squared equals 22 squared plus 18 squared minus 2 times 22 times 18 cosine B. I'm going to calculate this.
Sorry, I showed them.
256, 22 squared plus 18 squared, 808 minus 2 times 22 times 18, 792 through cosine B. Don't combine these two. Solve the equation using the order of operations. And then I'll divide by 792. That actually makes a nice fraction.
Mhm. Yeah, I saw them already.
45.8 degrees. So you've done all of this before. Choosing the correct rule to solve the problem. So ABCD is a parallelogram with sides AD is 5, DC is 10, and ADC. Find the length of the diagonals. First one I'm going to find is AC. We'll call it little d.
Yeah. Oh, yeah, we've totally combined these before.
Yeah, that one's easy.
And they cross at if it's a true parallelogram, they cross at the midpoint or the
The
midpoint.
midpoint, yes, of
So-
those.
And they told us it was a parallelogram, so.
That doesn't necessarily help us get this. But no, this is 120. Because we also know that those are. It would help us split this one in half, but not that one. So this is law of cosines. We'll call this one C. C squared equals. So 125 is the first part. Cosine of 60 is 1/2.
The hand mark.
Square root of 75 is D. D is 8.77. C is square root of 175. So I know cosine of 60 and 120. 13.32. So you did need to know the property of parallelograms that these angles. That parallel lines, interior angles add to 180.
Yeah.
That was definitely a lot of cosines. This one. Find the area of the quadrilateral. Okay, so remember area of a triangle, right? 1/2 AB sine C. So I'm going to do the two triangles here, which means I do need to get that.
Wait. We can solve for triangle BAD with the information that's there though, right?
Yes.
Okay. This. It smells bad. I mean, that's well, last. The same, it's not what I was saying. The worst part.
3.4. So then the area is 1/2 times 3 times 4 times sine 56 plus 1/2 3.4028 times 3 sine 63.
What else? Oh, no. Right, this is the fun.
9.52.
Yes.
And there we have it. This one, following shows quadrilateral. So I can use, what does it want me to find? Find the length of dB. So that's the law of sines. Oh, let's see.
No, it's not because all I have is guns. Outside of this sick person. Someone's going.
Apparently.
Do not throw the bells.
Yeah, I'm not sure how that's pajamas, but you know.
Just in general. I don't love them.
And then you use law of cosines to get this one.
I wouldn't like to hear myself every time I move.
So you get 6.11 for the first one. Then you use law of cosines.
This is like simple enough. I
Mhm.
think I understand.
This one.
Oh, we only have two pieces of information. Interesting.
So there are two triangles. Oh, it does. There are two triangles here.
Draw an angle and make two right triangles.
There's going to be another one here. One that tucks in and one that goes out. Find the area of both. Tangent of A is 5/7. Okay, so they're going to tell me that's an interesting way of telling me A. I'm going to use the inverse tangent of that. So this is 35.5. They want me to do this to get this angle.
That makes
That's a very IB question.
that makes a lot of sense, but I wouldn't have done that.
Yeah. I was like, wait, they didn't give me oh, they gave me the tangent. And that's a lot of experience doing this. So now I'm gonna get angle C. And it's actually gonna give me this angle C. Because the inverse sine will give me the acute one. This is obtuse.
Oh. Are they both? They're both angle C.
Mhm. We're gonna call it C1 and C2. Sine of C2 over 12 equals sine of 35.5 over 7. And because I'm supposed to keep using exact, I'm going to store that value as A on the calculator. So this angle here is 85.1. The obtuse one is 180 minus that. Does that make sense? Thinking about the unit circle? The sine of this is the same as the sine of that because sines have y coordinates. So this angle, what I'm interested in is 180 minus 85.1.
Is from A to C2 a straight line?
Yes.
It is? How? Okay.
Yes, you can keep a straight line and tuck a 7 in. It's a little easier to see with some of them if I draw it.
That makes sense. I thought that there was another unknown angle there.
No,
Perfect. No.
I just can't draw a straight line.
Does make sense then. Well, I.
So this is 94.85. 86.
You're just now giving them the IA guide?
Well, we have it online.
Oh.
It's been on Cognity.
This is a hard cut.
Yeah, I didn't bother to print it.
Want it? I
So-
printed enough for you.
So then this angle B1 and B2. B2 is 180 minus 85.142 minus 35 point.
Yeah.
$59.32. So now that I've got these two angles, now I can use 1/2 AB sin C on both of them. That makes sense. Several steps, none of them all that hard. And that's it.
Okay.